Greetings and welcome to lecture 8.2 area. In this video we're going to discuss ways to calculate area of multiple geometric shapes including squares, rectangle, triangle, polygon, as in parallelogram, as well as circle. So we've already done a couple of these in terms of square and rectangle. The new one that we're going to concentrate on is a parallelogram. So for the square, it's just going to be side times side, side squared. And if our side is called S, then it's S squared. For rectangle, to calculate the area, it's going to be length times width, or A equals LW. For a parallelogram, it's going to be the height multiplied by the base. So base times height, so B times H. We've already worked with the area of a triangle, which is 1/2 the base times the height, or 1/2 BH. A new one is how to calculate the area of a circle. The formula is the area of a circle equals pi r squared. Now, I'm not going to show you exactly how this formula is created or how you come up with this formula. We're just going to use it. So here's an example. A parallelogram has the base of 5 centimeters and the height of 2 centimeters. Find the area. And if you remember, let's go back to see what a parallelogram is. A parallelogram is two lines that are the same length connected diagonally or at a slant with two lines that are also the same length. So think of it as a rectangle kind of skewed a little bit. So if that's the case, we're going to use our formula for the area of a parallelogram, which is base times the height. In our situation, the base is 5 centimeters and the height is 2 centimeters. So 5 centimeters times 2 centimeters, 10 centimeters squared. So why is the area of a parallelogram A equals BH, or the area equals the base times the height? So think of it like this. If I take two parallelograms with the base and with a height, what I can do is using this height straighten out this one edge and relocate this triangle to the other side. I come up with a rectangle with the length equaling the base and the height equaling the width. Therefore, it's just like a rectangle, length times width. This is base times height. Let's try the example. The triangle below has a base of 6 centimeters and the height of 3 centimeters. Let's find the area. So I just drew a picture of a triangle with the height of 3 centimeters and the base of 6 centimeters. Sometimes it's nice to see it visually. I'm going to use my equation of area equals 1/2 the base times the height. 1/2 base times height. So 1/2 6 centimeters times 3 centimeters. So that gives me 1/2 times 18 centimeters squared, because remember we are multiplying centimeters and centimeters. And that leaves us with 9 centimeters squared would be the area of the triangle. Now let's apply what we've learned so far, and let's say we have a square stamp, like a stamp you would put on an envelope, and each side is 35.0 millimeters. What would the area be? So an area of a square is side squared, so 35.0 millimeters squared is going to be 1,225 millimeters squared. Now let's consider a stamp in the shape of a triangle. And the base is 2 5/8 inches and the height is 1 1/4 inch. And let's round this to the nearest hundredth. So we don't want fractions, we want decimals in the end. So I do know my area for a triangle is 1/2 base times height. So my base is 2 5/8 inches. And my height is 1 1/4 inch. So I'm going to convert my mixed numbers into improper fractions. And again, this is just multiplying fractions, so it's straight across. 21 times 5 is 105. 2 times 8 times 4 is 64, giving me approximately, and I rounded, 1.64 inches squared. We do want to remember to put in our units, and with area, our unit is always squared. Let's try one more. So now our stamp is in the shape of a rectangle with the length of 1.56 inches and the width of 0.99 inches. And again, we're going to round this to the nearest hundredth. A rectangle, the area of a rectangle is length times width. So it's 1.56 inches times 0.99 inches, giving us 1.54 inches squared. That's just a straight calculator problem if you want, or you can do it off to the side and multiply the long way. All right, let's try one of our new formulas. Find the area of a circle stamp with the radius of 14.5 millimeters. And again, we're going to round this to the nearest whole number. Okay, so my area of a circle is pi r squared. My radius in this instance is 14.5 millimeters. I'm going to square it. We are going to use 3.14 as an approximation of pi. So I'm very particular on this. It's an approximation. It's not exact. When I'm actually using the Greek letter pi, it's exact. But as soon as I estimate pi to be 3.14, it's no longer equal. It is an approximation. So 3.14 times 14.5 millimeters squared. 14.5 millimeters squared ends up being 210.25 millimeters squared. And lastly, 3.14 times 210.25 millimeters squared will give me 660.185 millimeters squared. I'm going to round to the nearest whole number, so that gives me approximately 660 millimeters squared. Now, lots of times in the world, we actually want to figure out the area of an object when something's inside it, and I want to know what's the area around it. For example, I want to find out what the shaded region, what this area is, but I don't really have a fancy formula to figure out the green area. But if I'm clever, I can figure it out. One, I know of a formula that will give me the area of this circle. So the diameter is 12 feet for this circle. As well as I do have a formula to figure out the area of the square that it's kind of sitting on top of. And therefore, if I figure out the area of the square, figure out the area of the circle, and take the difference, I will get the remaining portion of the green portion. So in essence, find the area of the square, subtract the area of the circle, and you'll have whatever is left over. So let's try that. Okay, so I've written down my formulas for both my area of the square and the area of the circle. Now the length, my side of the square, is the same as the diameter of the circle. So my area of my square will equal 12 squared, or area of my square will be 144 feet squared. Don't want to leave off my units. Now my area of the circle is pi r squared. Well, my radius will go halfway. So what's half of 12? Is 6 feet. So my radius, it's going to be pi times 6 feet squared, which would give me 36 pi feet squared. I'm going to approximate pi to be 3.14. So 36 3.14 feet squared. This is giving me the approximation of 113.04 feet squared. Now I'm going to round that to the whole number, so I'm going to go ahead and say that it's approximately 113 feet squared. Now remember, what I really want, and I'll go ahead and say it equals that, although we know it's an approximation, Now I need to find out the green area, and that's going to be my area of my square minus the area of the circle. So the area of the green is going to equal 144 feet squared minus 113 feet squared for the grand total of 39 feet squared. That is a 3, 39 feet squared. That's all you have to do. You do have to kind of take a step back, look at the object that you're trying to find the area for, and see, using what you know, figure it out, whether it's you have to add two areas together or subtract one area from another. Usually if they're sitting on top of one another, then you're going to use subtraction. If they're kind of sitting next to each other, then it's going to be addition. Let's try a little bit more complex problem. In essence, let's find the area of this shape. It looks like I wouldn't be able to figure this out, but let's take it in smaller chunks, using what we know to solve for the big shape. First thing is, I have a triangle. I have a formula for the area of a triangle. The center part looks like a rectangle, so I can use my area of a rectangle to solve for this portion of the shape. And lastly, I have a half a circle. So if I found the area of a full circle and divided it by 2, I would have the area of this last little bit. So I just wrote down my formulas, and remember this area is the area of a full circle. So at the very tail end, I'm going to divide it by 2, and then I'm going to add all of it together to actually get the area of this full object. So the area of the triangle portion is going to be 1/2 the base, 2, I'm going to go ahead and leave off all the units for now just to shorten my writing, times the height, which is 4. Well, 2 times 4 is 8. Half of 8 is 4, and that's going to be square miles. That's my area of the triangle. My area of the rectangle, equals my length, which is 6 miles, and multiplied by my width, which is 4 miles. So 6 times 4 will get me 24, again, now miles squared. I don't want to forget it, but I just don't want to have to write it over and over and over again. And then my area of the circle is going to be pi. My radius is going to be half of the height here. Right? If this is the half of my circle, that's going to be 2 miles. So 2 squared, that leaves me with 3.14 times 4. That will give me approximately 12.56 miles squared. Now, 4 miles squared plus 24 miles squared plus 12.56 miles squared will give me 40.56 miles squared. So again, break it down into smaller bits and then add it all together. Now it's your turn. Go ahead and find the area of this shape, and in our next class session, go ahead and turn it in for credit. So until then, be seeing you.